Hello everyone. We're going to talk about polynomial long division, or as it can be called, algebraic long division. But before we begin talking about polynomials, let's just go back to some arithmetic with long division and have a review of terms. For this problem says 12 divided by 6. 6 is the divisor, 12 is the dividend. The answer is the quotient. Whenever you look at examples, it's important to look at simple examples, so that way it's more relevant. We're not thinking about the actual work. We're able to concentrate on, okay, what are we trying to discern from this? What do we build upon with this? So with what we have here, I'm saying 12 divided by 6 equals 2. The divisor is 6, the dividend is 12, the quotient is 2, and there is a remainder of 0. The reason there is a remainder of 0 is because the divisor, 6, and the quotient, 2, are factors of 12, as illustrated here. 6 and 2 are factors. The answer to a multiplication product is known as, or a multiplication problem is known as the product. Factors of 12 are simply 1, 2, 3, 4, 6, 12. 1 times 12, 2 times 6, 3 times 4. Now we're going to take this basic concept of long division dealing with just arithmetic, and we're going to look at it how we can do it algebraically with polynomials. And we will begin with something that we've covered extensively, are the zeros of a function. We know that the zeros of a function are the x-intercepts. And the zeros of a function allow you to find the factors of that function, meaning I take a complicated, high degree polynomial and I can break it down to basic terms. These are the factors. Well, if we look over here, here are the zeros of a given polynomial. So what I know is that x equals 2 and x equals 1 and x equals a negative 2 and x equals 5. Therefore, writing those in terms that are factors, I say x plus 2, that's for the negative 2, and x minus 1, that's for the 1, and x minus 2 is for the 2, and x minus 5. All of these are factors. And how that is if I look at this and I say something like this, if I say, okay, x equals a negative 2, but I want to write it in the form of a factor, I need to pull that 2 over to the other side. In order to do that, I need to add 2 to both sides, so x plus 2 is equal to 0. Each factor, each one of these, will evenly divide the polynomial, as we can see up here. No matter any of the factors that I divide 12 by, it's going to divide evenly because they are all factors. So, given a polynomial, and we'll say it's the dividend, divided by another polynomial, a divisor, if there is a remainder of 0, then the divisor is a factor of the dividend, meaning that x plus 2 would be, being a divisor, would be a factor of this unknown polynomial. So let's take a look at that. Here is the polynomial in question, and I have x plus 2 is one of my factors. This is my polynomial. It is the dividend. This is the factor. It is the divisor. This polynomial up here is the quotient, and down here is the remainder. So let's just walk through long division step by step, explaining how we came about to come to here. It is just like arithmetic long division, except it's just a little more complicated. So the first thing I look at is I say, okay, x, what would it take for x to go into x to the 4th? Well, x cubed times x will give me x to the 4th. So I have to say x cubed times x and x cubed times 2. So x cubed times x is x to the 4th, and x cubed times 2 is 2x to the 3rd. Well, in your long division, slide this back over here, after you multiply the quotient and the divisor together, you get a number. Then you subtract. Well, here we have to do the same. I've multiplied those together. I come up with this, and then I have to subtract, which is the same as flipping the signs of each of those terms. More appropriately, it is multiplying through by a -1. I want to flip those signs, so x to the fourth becomes negative, and that's what the orange negative signs indicate, and 2x cubed becomes negative. Then I add them together. The whole goal is to always cancel out that lead term that we're looking at. That's what all of my math is based off of. So that becomes 0, and this becomes a -8x cubed. That's what I go off next, this right here. That's what's going to dictate what I look at x with. I drop down my next term. So I look at this one, and I say, okay, x times something needs to equal a -8x cubed, a -8x squared. I then take a -8x squared, and I multiply it to both of the terms, to the x and to the 2. So a -8x squared times x is a -8x cubed, which is what I want. I want them to end up being the same. And then I say a -8x squared times 2, -16x squared. I'm going to subtract them, so I flip the signs. What was negative becomes positive, which results in a 0. It's what I wanted. And then the math over here leads to a 17x squared. This is the lead term. This is what I'm going to base what I do next. I'm going to base it off of the numerical value and the power of my coefficient. And then I drop my 24x down. So I say, what times x will give me 17x squared? Well, 17x. I multiply 17x by x and 17x by 2. This is what I end up with. I am subtracting, so I flip the signs of each one. Gives me a 0. And then here gives me a -10x. Again, this is the term that's going to dictate what I do. I look at this and say, okay, what times 10 can give me a -10x? Well, a -10. So I take a -10 and I multiply it by x, and I say -10 times 2, which results in a -10x minus 20. Oh, I'm sorry, and I drop my -20 down also. I'm subtracting, so I flip the signs, do the math, and I end up with the remainder of 0. X plus 2 is a factor of the polynomial because my remainder is 0. Another way to look at it is just like this. These are factors. This is the divisor, x plus 2, this is the divisor, and this is the quotient. This is what I ended up with. If I multiply these together, my product is going to be the dividend. So if you want, pause the video and you multiply together. My lines right here that I've lightly written are to where I combined like terms, because I had like an x cubed, or a -8x cubed and a positive 2x cubed. So I'm combining my terms together. As I go through, I just slightly mark them out. And you look at this and you'll see we end up with the dividend. X to the fourth minus 6x cubed plus x squared plus 24x minus 20. Same thing. On a side note, with our long division, what you need to remember is when a term is missing. So you have x cubed plus x plus 2. It's missing the x squared. Because as we learned earlier, we write our powers in descending order. Well, there isn't an x squared. You need to fill that in. 0 is a place saver. So I simply write 0x squared. 0 times anything is 0, so really I've written nothing here. I've just saved the place for that x squared value whenever I go through. And as always, if you're given a problem and the powers of the terms are jumbled in the problem, rewrite it into standard form where the powers are descending. You have your lead term with its highest power and descending down. Alright guys, this is part 1. We'll have another part for the polynomial long division, but please watch your instructors or the publisher's videos, structure and critically think about your homework, and then look at the next video. Thank you.